Now what the heck is concentricity? Well, if we look at this bullet, this cartridge, from the meplat of the bullet straight at us, and we rotate it a little bit, what the concentricity is all about is we want the meplat, the tip of this bullet, seated exactly in the center of the cartridge itself, so that when it leaves, when the bullet leaves the mouth of this case, it's started out as straight as possible to fly down, travel down the bore as straight as possible, exit the muzzle as straight as possible, and so on. It's the real deal. Concentricity, bullet concentricity is the real deal. It will impact your accuracy. It will influence it. You can really not tell, though. I mean, unless it's really, really bad. You really can't tell just by looking at it. You got to put it on a gauge to determine that. Okay, this is a Redding competition, as it's called, competition bullet seating die. I really like this. This is very high quality. I really like the fact that we can make adjustments to the bullet seating depth very, very easily and precisely. So what I'm going to do is I have a 1.52 setting in place right now, and I'm experimenting with the bullet seating depth on these Lapua Scenar-L 90 grain bullets for 6mm or 243. These are the Scenar-Ls. And I'm experimenting on the bullet seating depth. I'm going to try this 1.52. It did not really like my Ruger number 1. I really didn't like a very long seating, if you want to call it that. Didn't really shoot very well with that. It shot pretty darn well with the 1.52 setting. And I'm going to try 2 settings. Five of them at 1.52, and then another 5 at a setting that I call factory setting. I took some factory loads and measured them inside this seating die and matched it, and so I'm going to seat 5 of these bullets at that depth and then test the accuracy, 5-shot groups off the bench out at the shooting range. Okay, we can see that this is now set at 1.5. One rotation around is 0.5. You can see that line right underneath it. We just barely hit the 0.5, and then 2 graduations after that, so we're at 1.52. Now I'm going to change this. I'm going to lower it to a 1.0 8. 1.08 is what I measured the factory ammo was set at. Now these units are just kind of an index units. It doesn't mean inches or anything like that. But right now I have this thing set at 1.08, and we're going to load 5 at that. We have it. Looks perfect. Test it against the factory. Yeah, that's about identical. Very good. I'm going to keep these separated so I know which is which when I put them into my case for firing and testing. You know, a lot of rifles, they do good when the bullet, especially these kind of long bullets, when they're seated just off of the lands, just off of the throat of those lands. So I have some rifles like that. My 220 Swift is like that. It loves those bullets kind of stuck out there. I thought it would be the same thing with my 243 Winchester Ruger number 1. That's not the case. In fact, it shot quite a bit worse with the long bullet seating, if you want to call it that. And so now I'm wondering if a nice factory style seating or this 1.08 seating will be even better, and I'll find out. That's the process right there. It's a very nice die, Reading competition die. Alright, now what we're going to do here is test the concentricity of these bullets. This is a Hornady lock and load concentricity gauge. Looks pretty complicated, but really it's not terribly difficult to use. I'm going to loosen up this thing, move it out here a little bit. I'm going to test the factory seated, if you want to call it that, kind of the short seating bullets first. I'll move this out of the way here a little bit. Give it some room to work. Move this in here and seat this right inside the dimple in this. And what we're going to do is we're going to push this so it so this ball mounted here does not make contact with this cast steel assembly itself. So I'm just going to push that out about 1/8 of an inch or so and tighten her right up. There we go. Now we're going to slide this thing so it makes contact. So this little gauge mechanism here, looks like a little ball bearing inserted in here, makes contact with the ogive of the bullet itself. That's that curved part, the curved part of the bullet. Effectively, we want that gauge itself to sit right in this area here. Now I'm going to tighten up this. Okay. Now on this gauge itself, I am going to turn it to 0 so that the bar or the indicator arm points exactly at 0. Now the rest of this is we're simply going to turn the case, and I'm watching that gauge. Okay, now it has dropped below the 0 mark, so that's my low point right there. I'm putting it back to 0 from the low point. Now I'm going to turn that again. Okay, it is just over the concentricity right here. One of these graduations is 1/1000th of an inch, and so the graduation is indicating that it's over, just slightly over 1/1000th of an inch. I'm going to go back to the low point, and now I'm going to tighten this up. So the low point right here is resting against the needle or the gauge itself, which means that the part that's out of whack the most, right, is pointing this way. So what I'm going to do is I'm going to tighten this up, put a little pressure on it to push the bullet in that direction, and loosen it back up, and now rotate it once again. I think I did a pretty good job there of removing. Yeah, I removed a little bit. We're at essentially 1/1000th of an inch, which isn't bad. That's certainly very good. So this is a nice bullet. I'm going to put it into the box. It is finished. I'm going to make sure that all my bullets, usually I like to make sure that all the bullets that I'm shooting are 0.0015 or less. If I can get them better than that, I'm quite happy. So again, I've put a new round in there. This one looks really good right from the factory. It's a nicely made bullet. There's my low point. I'm going to rotate this around to test it. Okay, I am well below a thousandth of an inch, and in fact I'd say it's about a half of a thousandth of an inch, or a 10,000th of an inch, 5/10,000ths of an inch. So that is really good. That's a nice round right there. Consistency is the importance, really. So I'll continue doing all these, and that's the process. Very, very nice tool. Works very well. And the nice thing I really like about it is we can actually correct the concentricity. When I did that with my .338 Winchester mag, Ruger Model 77, I noticed that some of the Barnes bullets that I was shooting in it weren't as accurate as I wanted them to be. They were tipped triple shocks, 225 grain bullets. Wasn't really getting the accuracy that I wanted out of them. Tried lots of different things with it, and then I put it on this Gage, and I noticed that they were kind of out of whack for concentricity. I corrected it, and then I did another 5-shot group, and it is now a sub MOA, or just at 1 MOA type of rifle. So that can make a big difference from a unsatisfactory load to a really nice load coming out of these things. So I tested 3 bullet seating depths out at the range. One where the combined overall length was 2.67 inches. A second where the combined overall length was 2.715. And a third where the COL was 2.857. Now that one, the bullet was seated just off of the lands. And the first one, the 2.67, is effectively the same as a factory seating. The result was an extreme spread of 1.052, or essentially 1 inch group, 5-shot group at 100 yards off of the bench, and that was the best group that was fired.